This module is on the optics of the eye. You've had a course on anatomy and pathology of the eye, where you spend a good deal of time learning about the anatomical parts of the eye, how they can become impaired, the causes of those impairments, and how they can express themselves in terms of functional vision. You also have perhaps spent time looking at and considering visual perception, how the brain takes information from the eye and processes it so that for what we call sight. What I'd like to do is, before we step into the optics, is spend just a few minutes quickly reviewing the anatomy of the eye, so that as we introduce some of the optics, you won't be trying to juggle your remembrance of the anatomy with the new information I'm going to give you on the optics. So briefly, the front surface of the eye is called the cornea. The cornea is also known as the window of the eye. It is clear and allows light to pass through it. Directly behind the cornea is the aqueous humor. The aqueous humor has a fluid called the aqueous fluid. Directly behind the aqueous is your iris. And the iris is also known as the colored part of your eye. It changes size to regulate the size of the pupil, which permits the amount of light, or regulates the amount of light to pass through. Light then strikes your lens, and the lens of your eye is used for accommodation, or it changes shape to focus images on the back of your eye. The largest chamber in your eye is known as the vitreous humor, and it contains a gel-like substance called vitreous. The back outside portion of the eye is called the sclera, and you can actually see the sclera on a human being, because you see a little bit of it as the white of your eye. And it is white the entire way around, but you only see a very small part of it. In the back of your eye, we have our retina, which is the photosensitive portion of the eye that creates electricity that we send back into our brain. Within the retina is the macula, and that is the black spot that's on the retina in this image. And the macula is the area which has cones which allow you to have color vision, 20/20 vision, and your crisp vision, or your straight ahead vision. And then we have this large black spot is your optic disc, or your optic cup, and that is your physiological blind spot, and it obviously is the connection for your optic nerve, which comes out of the back of your eye, goes all the way into your brain, which is where you see. These lines, these two lines, are parallel lines, and they indicate how light travels through the cornea, the aqueous, passes through the pupil, through the lens, through the vitreous, and then strikes the retina, and hopefully being in focus. Parallel light rays travel that way to the retina, where you create this photochemical response that allows you to see. So, we now want to talk about the optics of the eye. We begin by acknowledging that the eye is in fact an optical system. It refracts light or bends light. You're going to hear me use the term refract, refraction, refracting. I'm going to be using that a lot in the next hour or so. And basically all that word means is the bending of light rays. Now, there are four types of refractive errors, or refraction meaning bending errors, bending types. They are emmetropia, myopia, hyperopia, and astigmatism. Emmetropia is spelled E-M-M-E-T-R-O-P-I-A. And we're going to begin with emmetropia. Now, emmetropia, as it turns out, in fact, is the absence of a refractive error. That is the person who is wearing no eyeglasses, no contact lenses. They have light rays that come in parallel and focus on their retina without any external assistance. Excuse me. This person is emmetropia. Now keep in mind, this does not mean that the person sees 20/20 vision. It simply means that light rays focus on this individual's retina. A person, and what's happening here is that optics is about the focusing or manipulation of light rays. It doesn't say anything at all about what the person sees. It simply means we are taking light rays and placing those light rays on a retina. To see, the retina has to take those light rays and create electricity that goes back to your visual cortex, and that allows you to see. So one of the very first and most important principles is that refraction does not necessarily tell you what a person sees. It, in fact, is possible to take an individual who is totally blind but has eyes and to refract them and to say that they are emmetropic. Light rays focus perfectly on the retina of that person's eye, but there's something that's not working either at the retina, the optic nerve, or the visual cortex that's causing this person to not see. So to repeat, the optics of the eye are simply describing light rays focusing on the retina. They are not telling us how much that retina sees. So our next refractive error is known as myopia. And you can think of myopia as being nearsightedness. That is the layperson's term for myopia, nearsighted. And when you are nearsighted, the image focuses in front of the retina, and this causes defective distance vision. Sorry about that. And here's a schematic of the person with myopia. They have the same eye, parallel light rays come in, they go through the cornea, they go through your lens, and they focus. However, they focus in the vitreous. They focus in front of the retina, and then they splatter against the retina, causing blurry vision. So the person who has myopia has too much bending power. Why do I say too much bending power? Because it focuses at a point before where it really should focus. If the eye had a little more relaxation to these parallel light rays, they would focus on the retina, like the emmetropic eye. The myopic eye does not have that. The myopic eye has too much bending power, focusing in front of the retina and causing a blurry image. So to repeat, the myope, layperson's term for that is nearsighted. The image focuses in front of the retina, and they have defective distance vision. How much defective distance vision they have depends upon how much myopia they have. So the functional impact of myopia is blurred vision at far in the distance, and again, it's dependent upon how much myopia they have. This person is going to want to move objects of interest closer to see them. So if they don't have their glasses on or if they're not corrected, the only things they can see are objects which are up close. Myopes oftentimes will squint to be able to see something a little bit better, and if they're not corrected, they will avoid doing work at a far distance because basically you can't see clearly in the far distance. The opposite of myopia is known as hyperopia, and hyperopia is layperson's term for hyperopia is farsighted. And with farsighted, the image focuses behind the retina, and by focusing behind the retina, this causes a defect in the individual's near vision. Here is our same eye schematic. We will not be changing the eye schematic at all. We have our same parallel light rays. So the parallel light ray image goes to your cornea, goes to your lens, goes back to your retina, and notice that it never focuses on your retina. It in fact focuses its theoretical point someplace in your brain. It obviously never gets there. What it does is it simply splatters on your retina in the macular area. So the hyperope doesn't have enough bending power. The hyperope is the opposite of the myope. The myope has too much. The hyperope doesn't have enough. To correct for this hyperope, we need to bring this theoretical focal point closer to the retina. We need to have more power. We need to increase our power so that it will focus on the retina. So, to review, our hyperope is farsighted. The image focuses behind the retina. This individual has defective near vision. The symptoms and the functional effects of this, we've already said they're blurred at near. This person could also have blurred vision at the far if their hyperopia is high enough, large enough. So depending on how much hyperopia they can have problems seeing up close as well as seeing far away. But that is dependent on the amount of hyperopia they have. The hyperope also will have discomfort in reading. Why? Because they don't have enough power in their eye to be able to read. These folks will often complain about headaches when they're reading, and there will be quite a bit of avoidance of doing close work. Again, all dependent on how much hyperopia they have. But as a general statement, those problems will present themselves. The next condition is known as astigmatism. And with astigmatism, there is no single point of focus for this person. And the reason for this is because there is an irregular shape to the cornea or to the lens. And because there is this irregular shape, it creates distortions of the images. And here is our same schematic again, looking at an astigmatic or an astigmatism eye. Notice we have our parallel light rays, but when they go through the cornea and the lens, one of those light rays focuses in the vitreous, and one of the light rays goes back, again, behind the retina into the brain. So there is no consistent or no singular point of focus for the person who has astigmatism. So, to review, the person with astigmatism has no single focus, no single point of focus. They have an irregular shape to their cornea or to their lens, and they have distorted images. The symptoms, they will have blurred vision at near and at distance. They can experience some discomfort when reading, avoidance of close work, as well as some headaches. Again, it depends on how much astigmatism this individual has. So those are the four classifications, 3 of them refractive errors. The classifications are emmetropia, which means there is no refractive error. We have myopia, too much bending power, hyperopia, not enough bending power, and astigmatism, multiple points of focus.